Everyone, welcome to part test 9 chemistry paper discussion. Question number 26. In this, an optically active compound is given CH3 ethyl hydrogen OH, and it is treated with tosyl chloride. So this will convert OH into OTS. See, the purpose of the reaction is to convert OH into a OTS, which is a good leaving group. Now the substrate is treated with SH minus, which is nucleophile. So you will get the product, substitution product. Okay. So if here the configuration of the starting material is S configuration, in this particular reaction through SN2 the product should be having R configuration. But in question it is mentioned that out of 1 mole 0.05 moles of product is giving rise to S configuration. See, this S configuration is only possible through SN1 reaction. In SN1 reaction, otherwise see in SN2 reaction the product should be R configuration. So S configuration product means there should be SN1 mechanism. In SN1 mechanism, the nucleophile will attack from both the sides. It will give 50% of R and 50% of S. So that means there is 0.05 mole of S, means there is also a R configuration product 0.05 mole. So out of 1 mole 0.05 mole of R and 0.05 mole of S, that is total 0.1 mole is reacting through SN1 mechanism. So that means 0.9 moles is reacting through SN2 mechanism. So the percentage of SN2 will be 0.9 out of 1 into 100, that is 90%. Option A will be answer. In this reaction, the first ketone is treated with methyl magnesium iodide CH3Mgi, and this is a nucleophilic addition reaction, and we will be getting tertiary alcohol. And this alcohol is, when heated with concentrated H2SO4, it will undergo dehydration reaction to get alkene. So this alkene, when treated with HBr in the presence of peroxide R2O2, you will get the product with bromine attached to less substituted carbon. So this reaction is called peroxide effect. Okay, so the correct option will be A. Here the correct sequence of reagents to prepare metabromoiodobenzene from nitrobenzenase. So this is nitrobenzene. So here nitrobenzene is first treated with bromine in the presence of iron. It will first give metabromo-nitrobenzene because the nitro group is a -M group. It will direct the electrophile to meta position. So this nitro compound, when treated with tin in the presence of HCl, it will reduce to NH2. Okay. So again this amine, when treated with NaNO2 plus HCl. Okay. So this will give aryl diazonium salt. So this step will give aryl diazonium salt N2 plus here bromine, and this is an intermediate. And without also isolation, if potassium iodide is added to the reaction mixture, the N2 plus will be replaced by, this N2 plus is replaced by I minus, K plus I minus. So you will be finally getting the final product. So the correct option for this is A. See, the option B cannot be the correct option, because suppose if you treat nitrobenzene with reducing agent, you will be getting aniline. And if you then treat this with bromine in the presence of Lewis acid, since nitrogen is an electron donating group, you will be getting the para-bromo product. But here we need meta-bromo product. So the option B cannot be the correct one. Which equilibrium in gas phase would be unaffected by increase in pressure? According to Le Chatelier principle, increase in pressure will result in the shift in the direction towards less number of moles. That means if you increase the pressure, the reaction will move in that direction where number of moles is less. For example, in option A, N24 is in equilibrium with 2NO2. Here, if I increase the pressure at equilibrium, the reaction will shift in the backward direction because there are less number of moles, that is 1 mole on the reactant side, whereas 2 moles on the product side. If you take for example option B, here there is N2 plus O2 giving rise to in equilibrium with 2NO. Here number of moles of the products and number of moles of the reactants are same. Therefore increase in pressure does not favor any direction. So the correct answer will be option B. So there is no effect of pressure here. The preparation of SO3 by reaction SO2 plus half O2 giving rise to SO3. So in this reaction SO2 plus half O2 giving rise to are in equilibrium with SO3. There are 1.5 moles of reactants and there is only 1 mole of the product. So here when we increase the pressure, the reaction will shift in the direction of the products because increase in pressure favors direction in which number of moles is reduced. Okay, so definitely if we draw a graph between percentage yield of SO3 versus pressure, we will the concentration of SO3 will increase with increase in pressure until equilibrium is established. Now this reaction is performed under different temperatures. This is T1, this is T2 and there is another temperature T3. So they are asking what will be the correct relation between T1, T2, T3. So this reaction is also an exothermic reaction as mentioned in the question. So for exothermic reactions, they are favored at low temperatures. Exothermic reactions favored at low temperatures. Therefore, at a given pressure, if you compare, the T3 is giving more product compared to T2 and T1. Therefore, T3 must be lower than T2, that must be lower than T1. So the correct option will be B. Reaction A to B follows first order kinetics. So this is a reaction A to B and it is a first order reaction. And here it is given that 0.8 moles of A to convert into 0.6 moles, it is taking 1 hour. And the question is, what will be the time taken for conversion of 0.9 moles to 0.675 moles? So for first order reaction, time, that is here 1 hour, is equal to 2.3 divided by K log base 10. Initial concentration is 0.8 divided by 0.6. So here this 0.8 divided by 0.6 is nothing but equal, it is 4 by 3. So similarly, here also for the second reaction, the time T will be equal to 2.3 divided by K log base 10. Initial concentration is 0.9 and final concentration is 675. So if you solve this, the ratio will be exactly equal to 4 by 3. So since the ratios are same, the time here also it will take 1 hour only and the correct option will be option A. The 2,2-dichloropentane can be best synthesized by, in option A, so this is pent 1 ion CH3, it is CH3, CH2, CH2, C triple bond CH. when treated with Cl2. So nucleophilic addition electrophilic addition take place 2 times. You will get electrophilic addition take place 2 times. You will get tetrachlorinated product, that is CH3, CH2, CH2, and there will be 2 chlorines on each carbon, and the hydrogen is there, Cl, Cl. So this is not the correct option. See, alkynes undergo nucleophilic addition twice, and alkenes undergo nucleophilic addition electrophilic addition once. Option B. So here there is a triple bond, and it is also pent1 CH3 pent and when it is treated with hydrogen, let us assume that it is partial hydrogenation. So you will get a cis alkene CH3 CH2 twice CH double bond CH2. Now this alkene when treated with chlorine, you will get vicinal dihalide, that is 1,2-dichlorine product CH3 CH2 2 times CHCl, and this is CH2Cl. So this is also not the product. For option C, pent1. So here CH3 CH2 CH2 C triple bond CH, when it is treated with HCl, H plus Cl minus, this reagent is asymmetric. Here the electrophilic addition take place following Markovnikov rule. According to this, the chlorine will add to carbon having lesser hydrogens. So you get CH3 CH2 CH2 CCl, and this will convert into double bond CH2. Again this alkene will undergo second attack by HCl. So here also the Cl part, Cl minus, will attack the carbon already having chlorine atom. So the final product will be CH3 CH2 CH2, and there is a chlorine and the second chlorine, and this will be CH3. So the correct option will be option C. In this reaction, first we have to find order of the reaction with respect to A and B. First, let us observe experiment 1 and 2. Here, when concentration of A is kept constant and B is doubled, rate increased 4 times. So from this we can understand order of the reaction with respect to B is 2. Similarly, you observe here the concentration of B in experiment 1 and experiment 3, these two. So when concentration of B is kept constant and concentration of A is doubled, see here, it is doubled. Again from 1 to 3, check the rates. The rate also doubled. See 6, and it is 1.2. That means 12 into 10 to the power minus 3. So we can say order of the reaction with respect to A is 1. From this we have to find the values of X and Y, these two. So for this I will take the help of reaction. So here I can take the help of reaction for finding X. Let's take for example 0.2 and 2 and 4. Okay, fine. So if we take experiment 2 and 4. Okay, from experiment 4 I write that rate. See, experiment 4 is this. So experiment 4 rate is equal to, what is rate? 7.2 into 10 to the power minus 2 is equal to K into concentrations of A and B. I don't know what is the concentration of A. I take it X. I know the order is 1. and concentration of B is 0.2 and order is 2. Okay, and from experiment to 2, again the rate is equal to, what is experiment 2 rate? It is 2.4 into 10 to the power minus 2 into K. Again here in experiment 2, concentration of A is 0.1 given, order is 1, and concentration of B is 0.2 and order is 2. So now I will take ratio between these two. Okay, so here 2.4 and 3, so this is 3 by 1 is equal to, and for this one these two get cancelled, and K get cancelled, so this will be x by 0.1. So finally I get x is equal to 0.3. So here we have found that this is 0.3. Now we take experiment 4 and experiment 5. So from experiment 5, I know that rate is equal to 28.8 into 10 to the power minus 2 is equal to K into concentration of A is 0.3 power 1, concentration of B we don't know, that is Y. And from experiment 4, we know that again rate is equal to 7.2, R is equal to 7.2 into 10 to the power minus 2 is equal to K into concentration of A is 0.3, just now we find that, and concentration of B is 0.2 power 0.2 power 2. So we take the ratios here. Okay, so here 7.2 into 10 to the power minus 2, 28.8 into 10 to the, it will go for 4 by 1 is equal to, these two get cancelled, 0.3, and this is y divided by 0. So see, this is 0 point y power 2, this is y power 2 is equal to y square divided by 0.2 square. So if you solve this, y will be equal to 0.4. So the correct answer will be 0.3 and 0.4, answer A. So in this reaction, if you take any alkyl halide, treat this with AgNO3. See, this Ag plus will be combining with halogen part to give AgCl, and the R will be converting into carbocation. So the reaction will depend upon the stability of this carbocation. Okay, so here there are different alkyl halides given, and the option A, it will be giving rise to carbocation. So this is an aromatic compound and it is a stable compound. In option B, you will be getting a carbocation. It is aromatic compound, as well as it has also additional stability due to this electron donating methoxy group. So this is more stable than A also. And in C, you will be getting isopropyl cation, and in D, we are getting a secondary cation with NO2 group attached. Okay, so here the most stable is B, then A, then C, then D. See, D is less stable than C because NO2 group, electron withdrawing groups, destabilize carbocations. So correct answer is D, less than C, less than A, and less than B. So answer is C. Among the following halides, the one which reacts most readily with ethanol is, see, when alkyl halide react with ethanol, see, ethanol is a weak nucleophile. It is a weak nucleophile, and it is also a protic solvent. And ethanol cannot give SN2 reaction because it cannot attack from the back side. So this reaction will prefer SN1 reaction. Now there are 4 different substrates given. Option A. So SN1 reaction will proceed through carbocation formation, and definitely the one which forms stable carbocation will react faster. So in option A, para nitrobenzyl bromide will be giving rise to CH2 plus. This is the carbocation that is resulting. For in option B, it is para chlorobenzyl bromide. So the carbocation will be this. Okay. In option C, there is a para methoxy. And in option D, you will be getting paramethyl 1 CH2 plus. There is a methyl group. See, NO2 is a minus M group, and this is a minus I group. This is plus M group, and this is a electron donating group through hyperconjugation as well as plus ion effect. So electron donating groups stabilize carbocation, and among this methyl and methoxy, plus M group is more, plus M effect is more effective. So C is more stable. Therefore, the option C will react faster under SN1 condition. That means with ethanol. Here 3 leaving groups are given: CH3COO minus, C6H5O minus, and C6H5SO2 minus. Their corresponding acids pKa values are also mentioned. It is 4.5, it is 10, and here this will be 2.6. So low pKa value, that means it is a strong acid. So this is the strongest acid, and this will be the weakest acid. So strong acid gives rise to conjugate base which is more stable. So we can say C6H5SO2 minus is more stable, and C6H5, so here it is weakest acid, so we can say this is least stable. Yes, this can be explained through resonance also. So we can relate the stability with respect to leaving group ability. Since C6H5SO2 is more stable, it will leave easily. So it will be C6H5SO3 minus, then CH3COO minus, and C6H5 phenoxide ion will be poor leaving group. Option A will be correct. We have to find the pH of mixture of HCl and H2SO4 here. So pH will be equal to minus log hydrogen ion concentration. So here we have given mixture of HCl and H2SO4. So the concentration of H plus will be equal to total number of moles of H plus divided by total volume. So number of moles of H plus will be coming both from HCl and H2SO4. So this we can get by molarity into volume into n factor of HCl plus molarity into volume into n factor of H2SO4. This will give the total number of moles of HCl plus H2SO4 molecules divided by V1 plus V2. This will give the concentration of H plus. So here molarity of HCl is 0.01, volume is 200 ml, and n factor is 1 because HCl will produce only 1 H plus ion. For H2SO4 molarity is 0.01 and volume is 400 ml and n factor is 2 because H2SO4 is a dibasic acid. And volume is 400 plus 200, this is 600 ml. So 0.01 into 200, this is 2, and this will be 8. So total this is 8 plus 2, that is 10 by 60, that is 1 by 60. So hydrogen ion concentration is 1 by 60. Now pH will be equal to minus log 1 by 60. So if you solve this one, you will be getting pH is equal to plus 1.78. Option will be option B. In this reaction we have to find the product as well as the reaction mechanism. So in the first option, methoxy, this product, the starting material methoxy substituted 1 reacting with nucleophile. Okay, and it is giving rise to some nucleophilic substituted product OCH3 CH2 Nu. And similarly, in another reaction we have nitro substituted product NO2 CH2Cl, and it is also reacting with Nu to give CH2Nu. This is NO2. So here, see here, OCH3 is a electron donating group. Electron donating group stabilize carbocations. So this reaction will proceed through SN1 mechanism. And SN1 reactions are first order reactions. Here NO2 group is a electron withdrawing group. Electron withdrawing group destabilize carbocations. So this substrate will try to avoid carbocation formation. So it will prefer SN2 reaction. SN2 reactions are second order reactions. So the correct option will be reaction 1 is first order and reaction 2 is second order. Option will be C. Here 2-methyl propyl bromide. 2-methyl propyl bromide is treated with C2H5O- and ethanol separately. So here it is treated with ethanol separately. The question is about the product and the mechanism. So here C2H5O- is a strong nucleophile. And SN2 reactions are characterized by strong nucleophiles. So this reaction is a SN2 reaction. Again, in SN2 reactions there will be no rearrangement of the product observed. So you will be here C2H5O-, so this will attack this carbon, this will undergo substitution, so the final product will be OC2H5. so this is SN2 and isobutyl ethyl ether. Here in the second case, so it is a weak nucleophile. Will prefer SN1 mechanism. So in this reaction, SN1 reactions, the first step will be formation of the carbocation, and carbocations are very susceptible to rearrangement. So this will rearrange to most stable tertiary butyl carbocation, and this will get attacked by ethanol finally to give tertiary butyl ethyl ether. So the second reaction is SN1 reaction with tertiary butyl ethyl ether as the product. Option D is the correct option. In this we have to find the relation between Kp alpha means degree of dissociation and total pressure at equilibrium. So for example, if I write this as A giving rise to B plus C by 2. So if I assume that we started the reaction with 1 mole and alpha is the degree of dissociation. So for alpha mole there will be alpha moles of B formed and alpha by 2 moles of C is formed. So at equilibrium the total number of moles Nt is equal to 1 minus alpha of A is left and alpha amount of B and alpha by 2 amount of C is formed. So here these two get cancelled, so N total will be equal to 1 plus alpha by 2. So now the equilibrium constant Kp will be equal to, because it is a gaseous reaction, the partial pressure of B into partial pressure of C power of divided by partial pressure of A. Here partial pressures are not mentioned. So partial pressure can be obtained through Dalton's law, where for example partial pressure of a gas X will be equal to number of moles of X divided by total number of moles at equilibrium into equilibrium pressure P total. So similarly you can get partial pressure of B. It will be equal to, what is the number of moles of B? This is alpha. So this is alpha by, and the total moles will be alpha 1 plus alpha by 2 into P total. Similarly, partial pressure of C can be obtained as the number of moles of C is alpha by 2 and the total moles is 1 plus alpha by 2 into P total. This can also be written as Pc is equal to alpha by 2 plus 2 alpha by 2. So I am multiplying this and these two get cancelled. P total is here. So finally I get alpha by 2 plus alpha into P total. And partial pressure of A will be equal to 1 minus alpha divided by 1 plus alpha by 2 into P total. Now we have got partial pressure of B, partial pressure of C, we shall use this one, and partial pressure of A. Now I will substitute this in the equilibrium constant Kp. Kp will be equal to partial pressure of B will be alpha divided by 1 plus alpha by 2 into P total. Okay, and partial pressure of C is alpha divided by 2 plus alpha into P total power of divided by partial pressure of A will be 1 minus alpha 1 plus alpha by 2 P total. So some of this can get cancelled here. So these two get cancelled and PT get cancelled. So now this we get to the final equation. So here alpha power 1, this is alpha power 1 and this is alpha power 1 by 2. Alpha power 1 by 2. Okay, so this is done. And here I have here I have 1 minus alpha, this one, and 2 plus alpha. So this 2 plus alpha is power of, and there is a P power of also. Okay, so this will become alpha 3 by 2 P of divided by 1 minus alpha 2 plus alpha 1 by 2. So the correct answer will be option C. Question number 41. Here SO3 is converting into SO2 plus O2 and has reached equilibrium. So for this Kc value is given as 4.9 into 10 to the power minus 2. Okay. So the question is about what is the equilibrium constant Kc for the reverse reaction 2SO2 plus O2 giving rise to 2SO3. Since it is a reverse reaction, the new equilibrium constant K will be equal to 1 by 4.9 into 10 to the power minus 2. Since it is multiplied with 2, so this will be squared. So I will consider this as 5. So I will get 1 by 5 into 10 to the power minus 4, and this will be 10,000 divided by 25. So this is square of 4.9 or 5 will be 25. So this will be nearly equal to 400. The correct answer is 416. So here we have two solutions, HCl and BaCl2. Two solutions, NaCl and BaCl2. So through both of these solutions, HCl is passed. HCl gas is passed. Okay. So the first statement, second statement both say that on passing HCl, both NaCl and BaCl2 get precipitated, which is correct. Get precipitated because it is due to a concept called common ion effect. So both the statements are correct. So according to Arrhenius equation, rate constant K will be equal to A into E power minus EA by RT. So then ln K will be equal to minus EA by R 1 by T plus ln A. So this is in the form of y is equal to mx plus c. So if we draw a graph between ln k versus 1 by t, we get a negative slope that is equal to minus ea by r, and the intercept is ln a. So this is the correct option, option D. For the reaction 2A giving rise to B plus C, the equilibrium constant Kc is equal to 4 into 10 to the power minus 3. So for this reaction, at a given condition, if a reaction mixture is analyzed, they have found that concentration of A, concentration of B and concentration of C, they are all equal to 2 into 10 to the power minus 3 molar. Now the question is about the direction of the reaction. So for this we have to find reaction coefficient. Reaction coefficient. Quotient. Quotient. Okay. So this is equal to concentration of the products, concentration of the reactants divided by raised to their stoichiometric coefficient. Here it will be power 2. So we know the concentration of B is 2 into 10 to the power minus 3. Concentration of C is also same 2 into 10 to the power minus 3. And concentration of A power 2 again it is 2 into 10 to the power minus 3 square. So these all get cancelled and we get this is equal to 1. So this is Q value. Now we can see that Q value 1 is greater than Kc value. So this is 1 and this is 4 into 10 to the power minus 3. So here under these conditions the reaction will move in the direction of backward direction, because for the reaction to become until the Kc and Q value become equal. So the reaction will move in the backward direction. The rate of reaction quadruples when temperature changes from 27 to 57 degrees centigrade. See, at 27 degrees centigrade, that means 300 Kelvin, let's say rate of reaction is K. At 57 degrees centigrade, so on increasing 30 degrees, 330 Kelvin, the rate is 4K. So the question is, what is the activation energy of the reaction? So from Arrhenius equation, log K2 by K1 is equal to EA by 2.3 into R 1 by T1 minus 1 by T2. Here this is given 4 times greater than this one. So I can take this as a log 4 is equal to EA by 2.3 into R is 19.1 and this is 1 by 300 minus 1 by 330. Okay, so if we solve this one, so log 4 is 0.6 is equal to EA by 19.1, this will be 30 divided by 300 into 330. So which is will go for 10 times. So this is 0.6 is equal to EA by 19.1 into 3300. So EA will be equal to 0.6 into 19.1 into 3300. Since we have taken this R in joules, so this is answer in joules. So now for getting answer in kilojoules, we will divide this with 1000. So this is 0.6 into 19.1 into 3.3. So this will be equal to 38.04 kilojoule per mole. So answer will be A. A liter buffer solution contains 0.1 mole of NH4Cl. So 1 liter of solution contains 0.1 mole of NH4Cl and 0.1 mole of ammonia. So to this, this is 1 liter solution. To this 0.102 mole of HCl is added. So HCl and ammonia will react to form NH4Cl, that is salt. So since here HCl is a limiting reagent, so the reacted amounts will be only 0.02 moles of ammonia will only react and 0.02 moles of HCl will react. Therefore, the final amounts will be, this will be 1 minus 0.02, that is 0.08, and this is completely consumed, and at the end 0.02 moles of NH4Cl is formed. So initially we have 0.1 mole and this is newly formed. So this is 0.1 plus 0.02. The total amount of ammonium chloride is 0.12 molar. And the total amount of ammonia left is 0.08 molar. So for a pH or pOH of a basic buffer is equal to pKb, that is 4.745 plus log concentration of the salt, that is 0.12 divided by 0.08. So this will be 3 by 2. So 4.74 divide plus concentration of this will be 0.48, 0.30. So the difference will be, let's see, 0.477, 0.301. So this is 0.16 and this is 7, this will be 0.176 plus 0.176. So again 4.745. So the pOH will be equal to 0.17656 and this is 82. So this is 29, 4.921. So this is pH. Again they are asking pH. So the pH will be equal to 14 minus 4.921. So this is 9. So this is 7 and this is 0, right? So this will be 0 and this will be 9. So 9.079. So the answer will be 9079. That will be the final answer, because they are asking in terms of 10 to the power minus 3. A first order reaction has rate constant K. So a first order reaction is there and its rate constant is given 4.6 into 10 to the power minus 3. So identify the correct statements, number of correct statements. So the first reaction is reaction completes in 1000 seconds. So this is wrong, because for a first order reaction T is equal to 2.3 by K log base 10 initial concentration by final concentration. So 100% completion means what? This final concentration is 0. So if you take A0 by 0, so this T will be infinite value. So theoretically first order reaction never undergo 100% completion. So the first statement is wrong. So second statement, reaction has a half-life 500 seconds. See, T off is equal to 0.693 and the K value is given 4.6 into 10 to the power minus 3. I write this as 10 to the power 3 in the numerator. So this is 693 divided by 4.6. It is nearly 150, but it is given 500. So this is also wrong. And option 3, time required for 10% completion. See, for 10% completion, it is 25 times greater than 90% completion. Definitely 90% completion take a greater time, more time. So the option C will be also wrong. Sorry, the option 3 will be wrong. And again, next one is fourth one. So according to the first ordered equation, it is A is equal to A naught into e power minus kt. So it will be A by A naught is equal to e power minus kt. So if I write this as 1 by 1 minus A by A naught, it will be 1 minus e power minus kt. So this can be further written as A naught. A naught minus A is equal to 1 minus e power minus kt. See, this term is nothing but equal to alpha. So what is alpha? Number of moles. Alpha is number of moles dissociated by n total moles. So if A is the initial and A naught is initial, A is final. So A naught minus A is the number of moles dissociated and n total, A naught is definitely n total. So this is a correct statement only. So this 4 is correct. The rate and let's see fifth one, rate and rate constant have same unit. So rate has molarity per second and rate constant is per second. So these are different. So this 5 is also wrong. So the only correct statement is option 4. So the number of correct statements are 1. In this 3 different reactions are given at equilibrium with K values and you have to get K value for the given reaction. Okay, so here the ammonia is present on the reactant side. Here it is present on the product side. So I can write this in the opposite direction like 2NH3 giving rise to N2 plus 3H2. So the K value will also be reversed. It will be 1 by 4 into 10 to the power 5. Here again there is NO in the product. So here NO is in the product side. So I can take it as it is N2 plus O2 giving rise to 2NO and equilibrium constant value is 1.6 into 10 to the power 12. And there are 3 H2Os and here 1 H2O. So we should multiply with 3. So 3H2 plus 3 by 2 O2 giving rise to 3H2O. So the K value will be 10 to the power minus 39. So the K value for this final reaction, this will be equal to 1.6 into 10 to the power 12 into 10 to the power minus 39 divided by 4 into 10 to the power minus 5 I will write here. So this will be 4 will go for this one 0.4 and this minus 39 and minus 5 is minus 44. Minus 44 plus 12, this will be minus 32. So this is 0.4 into 10 to the power minus 32 and 4 into 10 to the power minus 33. So here the answer is 4. In this question, SO2 is reacting with half O2 to give SO3 and all are gases. And here Kp value is given, that is equal to 2 into 10 to the power 12 and the question is Kc. What will be the Kc? So Kp will be equal to, we know Kc into RT delta N. Here number of moles of the reactants is 1.5 and number of moles of the products is 1. So delta n is equal to 1 minus 1.5, that is minus 0.5. So here now Kp will be 2 into 10 to the power 12 is equal to Kc into 0.0821 into 300 power minus half. So if you substitute if you solve this for Kc will be equal to, you will be getting 10 into 10 to the power 12, and the answer will be 1 into 10 to the power 13. So the final answer will be 1. Question number 50. Here there is 3 by 2 moles of O2 converting into O3. So again Kp value is given 2.47 into 10 to the power minus 29. And the question is delta G. Delta G will be minus RT to minus 2.303 RT log base 10 Kp value. So here we can substitute this minus 2.303 into 8.314, this is joules, into temperature is 298 Kelvin, into log base 10 2.47 into 10 to the power minus 29. So here you will be getting delta G 613 and 673 joules, and the question is answered in 167 joules, and they are asking in kilojoules. So you will be dividing this with 1000, so this will be answer will be 163 kilojoules will be the answer.